Hi everyone, it's Ms. Hancock again, and today we're going to talk about understanding a rational number diagram. So before we really get into the numbers, we're going to talk about just understanding how the diagram works, and then we'll go into putting numbers in the diagram, okay? So this particular part of the lesson is not about the numbers, it's just about understanding the diagram. So I love strawberries. They're like one of my favorite berries. So I've listed like some berries here: strawberries, blueberries, raspberries, and they're all berries. But can we classify them as something else? You can also classify them as fruit. So these berries, strawberries, they are part of the fruit family. But now let's look at the fruit family. We have apples and pears and oranges and grapes, and there's a lot more, but that's all I've listed here. So strawberries are part of the fruit family, and they're part of the berry family. But notice that outside the berry circle, apples is not part of the berries. So everything inside the big circle is part of the fruit family, but if it's outside of the berry circle, it's not part of the berry family. So it's important that you understand this concept. Also, what about food? A strawberry is a fruit. It is also a food. Oranges, not a berry, but they are a fruit and they are a food. Now, donuts, and we like donuts, as much as we want the donuts to be healthy and part of the fruit and berries, is not. The donuts is part of the food category, but because it's outside this circle, it's not part of the fruit, and it's outside the berry circle, so it's not part of the berries. But a raspberry is a fruit and a food. So I wanted you just get a good understanding of how that works. So now we're going to look at some vocabulary words, and we're going to talk about some vocabulary. The first thing we're going to talk about are the little dots. That just means numbers continue indefinitely. And to give you an example, like, so if I'm counting like 1, 2, 3, and I put ... after it, it just means that you're going to keep counting. You're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's just going to keep counting. Also, if I have numbers like -6, 5, 4, and it just means that there's a whole bunch of numbers before -6. So those dots just mean it just keeps going, okay? All right, so let's look at the next vocabulary word. It's called natural numbers. And this is so easy because it's just naturally how you count. If I say, hey, go count the pencils for me, and you start counting them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the way you count. You always start with the number 1 when you start counting. So that's how we naturally count. Notice the dots at the end that tell you that, hey, you can keep going. It doesn't stop at 10. All right, then whole numbers. Well, whole numbers are the natural numbers. So it's all plus 0. So if you're looking at that, it's 0, and then you're the way you naturally count. Now let's go and look at the next group of numbers. So on this group of numbers, integers are whole numbers and they're opposites. So integers are all of these numbers plus their opposites. So it's like 0 and 1, 2, 3, 4, 5, and it keeps going, but it's also the opposite. So -1, -2, -3, and so forth. But make sure you pay attention that decimal are these are whole numbers and their opposites. Okay, and on the last definition, rational numbers, it includes natural numbers, your whole numbers, your integers, but it also includes fractions and decimals that determine. So that's important to know that it will, any number that you get in a fraction, those would be a rational number, and any number that either you can terminate or a number that repeats, like the bar favorite, all of those numbers would be considered rational numbers. So now we're going to take a second and we're going to look at the diagram on here. So on the diagram, we have natural numbers, and you can kind of see it's got the same numbers that are in the vocabulary, 1 through 8. It's got dots telling you that it's going to go on forever. And then we've got whole numbers. Well, notice that 0 is the only number in the whole number section, but remember, it's everything inside the circle. So it's 0 and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so forth. It keeps going, but it's not just 0. So I want you to remember that. It's everything inside the circle. Okay, natural is everything inside this circle. All right, let's look at the next one. We're going to talk about integers. So with the integers, you have inside the integer circle, you have the natural numbers, you have the whole numbers, you have the negatives as well, the negative numbers. So it's everything that's inside of this circle. It's whole numbers and their opposites. Okay. All right, now let's look at one more section of it, and that would be rational numbers. Now, I want you to look at the only difference here. Okay, rational numbers is everything inside, so that includes all the natural numbers, whole numbers, integers, and also fractions and decimals. It's important on the decimal. You remember that it is terms. So repeat it. Those are the animals that are included. And you're probably wondering, well, isn't that all the numbers? No, we have some irrational numbers. I'm going to just write to the side. It's numbers that they never end. They don't have like the square of 2 and you got in your calculator, that would be an irrational number. If you did the square of 15 and you key it to your calculator, that is an irrational number. Okay, so if we're going to categorize these, let's just kind of talk about what would be negative. Well, as I'm looking here, I know that -2 is not a natural number. It's not a whole number. It's an integer, but it's also a rational number because it's inside the rational circle. So -2 is irrational, is an integer and a rational number. What if we looked at 1/3? What would 1/3 be considered? If there are no fractions in the naturals, there's not any fractions in the whole, not any fractions in the integers, but there are fractions in rational numbers. So 1/3 would be considered a rational number. What about the number 0? Well, 0 would be considered, it's not a natural number, but it is a number. It is an integer because inside the integer circle, and it is a rational number inside the rational circle. Let's look at one more number. Let's look at 10. So what would 10 be considered if we categorize it? Well, 10 would be a natural number because it's the way we count. It also would be a whole number because it's inside the circle of the number. It would also be an integer because it's inside the integer circle. And it's also a rational number because it's inside the rational circle. So if we're going to categorize, this is kind of the way that we would do it, and when we're trying to classify numbers as to what type of number they are. Now, if I ask you what is pi, which is a number that never ends and does not have a pattern, that's an irrational number. We're not really going to concentrate on irrational numbers. That's more of an 8th grade skill. But I wanted you guys to be aware that there is one more type of number, and that's an irrational number. That concludes our lesson on this video, and I hope you learned something from it, and I'll see you in the next video. Y'all have a great and wonderful day. Catch y'all later.